Hello guys, uh, a warm welcome to all of you. Myself Amar. I'm from second year CSCA. My roll number is 513 and today I'm going to make a presentation about multiple regression from the subject probability and statistics, which is well known as P&S. Okay, the introduction. Here we are going to describe some of the differences between multiple regression and bivariate regression and the importance of R square statistic, and we'll examine the F test and distribution and how to use the F test to determine the joint significance. Today we are going to discuss about these four topics. Multiple regression. In general, regression estimates are more reliable if the n value is large. It means it represents the dataset. If the dataset is big enough or large enough, then we'll be getting the answers precisely. And the sample variance of the explanatory variable is high. The variance of error term is small. The less closely related are explanatory variables. All these can be happen only when the data set is large. If a very small data set, there is a 50-50 chances for getting high value errors and precise answers. I hope you get it. And the constant and parameters are derived in the same way as the bivariate model, and when a new variable is added it affects the coefficients of existing variables. It means if we are going to add some of the values or some of the variables to the dataset that we considered previously, it affects the data, it affects the outcome, and it affects the errors. So we need to take the whole amount of data at a single time before we start the process, or we apply multiple regression. In the middle or at the end, if we add any kind of data or any variables, it may affect the outcome. And this is regression. In the previous slide, a unit rise in the x produces 0.4 of a unit rise in y with z held constant. Interpretation of t statistics remains the same. The r squared statistic indicates 30% of the variance of y is explained. And we'll be going to the next slide. Adjusted r squared statistic. This is the third one that we are discussing. The statistic is used in a multiple regression analysis because it does not automatically rise when an extraplanetary variable is added. Its values depends on number of explanatory variables. It is usually written as r bar squared. It means r upon bar and whole square. In generally, rises when the t-statistic of an extra variable exceeds unity 1, so does not necessarily imply the extra variable is significant. It has the following formula. Here you can see r bar square equal to r square minus k minus 1 by n minus k into 1 minus r square. Here it is the formula that you can see. And the final conclusion is multiple regression analysis is similar to bivariate analysis. However, correlated between the x variable needs to be taken into account. The adjusted r squared statistic tends to be used in the case. The f test is used to test for joint explanatory power of whole regression or a subset of variables. We often use the f test when testing for things like seasonal effects in the data. It means, um, let me tell you one thing. In this slide, you can observe the R square. We are telling that this R square is used for number of explanatory variables. Okay. And here in this formula, we are not going to use this adjusted R square value all the time. We'll be using this R square value only when there is an extra variable significant. That too, if it is exceeds the unity, it means if the value exceeds 1, then only we'll be using the adjusted R square. So that's the final conclusion, and I hope you got it. Thank you.